friends, I am MANAS from your Pyarasa channel, ARYABHATTA Career Academy. I don't care who stole my idea. I care that they don't have their own. The thing is that we have to care each other. Dear children, in previous video, you have given many comments. In fact, I have gone through that comment. Some reply I have given. Now I am unable to give all these replies, but I have gone all through this comment, and your comment is really inspiring me. I hope that what you are expecting from me, I shall fulfill. So, today's topic is regarding electromotive force. It is one of the important concepts after the potential difference. Previous video, I explained regarding potential difference. In this video, I am going to explain about the electromotive force of a cell. You might have seen cell, no doubt at all. How it is? So, in symbolically, I can write like this way. See here, children. In a cell, there are two electrodes. I have mentioned in the form of copper and zinc. Any cell, definite, you will find two electrodes. So here are two electrodes are there. One is made out of copper, one is made out of the zinc. Inside this cell, there is an electrolyte. Suppose I have taken here dilute sulfuric acid, or you can take it other chemicals also, no matter. For example, I have taken here dilute sulfuric acid. In fact, see that this is one electrode, this is another electrode. When H2SO4 dissolve in water, it breaks into hydrogen ions, at the same time sulfate ions. These ions inside a cell move in different direction, that is due to some chemical reactions. As a result, cell is able to supply energy to the charged particles to move. So, in a cell, the sulfuric acid break into hydrogen ions and sulfate ions. Sulfate ions move towards the zinc, whereas the hydrogen ions moves towards the copper rod. When sulfate ions, which is negative in charge, it moves towards the zinc rod, it emits electrons to the zinc rod. At the same time, hydrogen ions, which move towards the copper electrode, it gains the electron. As As a result, what happened? At the side zinc, number of electrons increases, whereas at the side of copper, number of electrons decreases. So I can say that there is a deficit of electrons at one end, there is excess of electrons in another end. That means here sulfate provided electrons to the zinc. As a result, zinc became negative. I can say it is lower potential. At the same time, the copper lost the electron, it became positive. So I can say that it became higher potential. This is represented by plus symbol. This is the lower potential. So I can say that a cell is capable to maintain a constant potential difference between its two electrodes. That constant potential difference between the two electrodes we say electromotive force. That constant potential difference between the two ends of the electrode we say electromotive force. So I can say that when a cell is not connected in a circuit, when a cell is not connected in a circuit, the potential difference between the electrodes is called electromotive force. Shortly we can write E.M.F. I have mentioned when the cell is not connected in a circuit, or you can consider that the cell is in an open circuit. That time the potential difference between the two electrodes we say electromotive force. It is generally represented by the symbol epsilon. Like the potential difference, its unity is also volt. There is no doubt at all. Its unity is volt. So, when a cell is connected in a circuit, in that circuit if there is an electrical component like electric bulb, what happens? The circuit, the chemical energy convert into electrical energy. As a result, electric bulb glow. So, I can say that the amount of work done or the amount of energy spent to carry a unit positive charge. See here, the amount of work done, or I can say energy spent per unit charge in moving a positive test charge in a circuit. Listen carefully. I have mentioned here complete circuit. Complete circuit means inside this cell and also outside this cell. That means external circuit as well as internal circuit. External circuit and internal circuit of a cell. The amount of work done per unit charge in moving a positive test charge in a complete circuit means this is inside the circuit, this is outside the circuit. The total work done for carrying a charge around the circuit, around the complete circuit, we say electromotive force. So I can say that mathematically epsilon is equal to W by Q. Potential difference also I said amount of work done per unit charge. Here also I am telling the amount of work done, but I am saying how much amount of work done for moving a positive test charge in a complete circuit throughout the entire circuit, external circuit as well as internal circuit. So mathematically I can say that epsilon is equal to work upon charge. Already I said its unit. Now let us consider what are the effects or what are the factors affect the electromotive force. It depends upon two major factors. One factor is the property or nature of electrodes. Nature of electrodes. It is one of the factor which decides the strength of the cell. Another factor, electrolyte or the chemicals what we have used inside the cell. It does not depend upon the size of the cell. It also does not depend the distance between the electrodes. It depends upon the nature of the electrodes as well as it depends upon the nature of the chemicals or the electrolyte what we are using inside this cell. So this is about the electromotive force. In another way I can say that the amount of work done on unit negative charge to move it from positive terminal to negative terminal of the battery. Like this way also we can say electromotive force, or I can say that the amount of work done on positive charge to drive it from negative terminal to positive terminal. One thing I said that when the cell is not in use, when the cell is in open circuit, the cell what you are purchasing from the market, suppose it is mentioned 1.5 volt. That means that 1.5 volt is the electromotive force because it is not in the circuit, or you can say it is in the open circuit. So electromotive force, it is one of the characteristic. So it does not depend how much current you are drawing from it. So different electrolytic cells are there. They have different capacity. For example, voltaic cell, its capacity is 1.08 volt. Or Daniel cell also same 1.08 8 volt. Generally the cell what we are using, Lakeland cell, its capacity is 1.5 volt. So I said it is the characteristic property of a cell. So I hope that you might have understood what is electromotive force. How can we measure that? Which instrument is used to measure it? Definitely the voltmeter is used to measure the potential difference by connecting it across the cells. By connecting across the cells, we can measure the electromotive force of that cell, and the cell is not in use. If it is cell in use, then we will get the potential difference or voltage. Now let us consider the second point what I mentioned here on the board, that is the terminal voltage. What is terminal voltage? Now children, don't forget to share this video to your friends. As a result, he can also get the benefit. Okay, see here. So now I can say that the cell is in use. That means the cell is in a circuit. So when the cell is in a circuit, the potential difference between its two terminals is called terminal voltage. What generally we say voltage. I can say that how much amount of work done or how much amount of energy spent per unit charge in moving a positive test charge, in a circuit across the cell. That means I want to say that how much work is done for carrying the charge in the external circuit. That time I said complete circuit. Now I am not using the term complete circuit. Now I am using the term external circuit. So I can say that the amount of work done, or you can say energy spent per unit charge in taking a positive test charge around the circuit across the two ends of the cell. Mathematically, I can write V is equal to W by Q. Already you have studied in electric potential difference. Same thing I have written, V equal to W by Q. Did you get me? This is about the terminal voltage. terminal voltage. I can say that how much work is done for carrying the positive test charge in the external circuit, not inside the cell. In case of electromotive force, work done for carrying charge both in external circuit as well as inside the circuit of the cell, but here only external circuit. So let us move to the third point, that is the voltage drop. So what is that voltage drop? Voltage you know. Then what is the voltage drop? That means a drop of the voltage. Yes, that is correct, but we have to discuss it. Its technicality. What is voltage drop? Listen carefully. Inside this cell, some chemicals are there. Definitely, there is some chemical reactions. Due to that chemical reaction, a cell is able to maintain a constant potential difference, which acts as a source of energy. Or you can say that is the energy for the charged particles or the electrons, or you can say that is the source for electric current. So what is that voltage drop? The thing is that when charged particles move inside the cell, some energy is spent, no doubt at all. Or you can say that work done per unit charge. Work done per unit charge, or you can say energy spent. Energy spent means work done. Work done means definitely energy spent. So work done per unit charge in moving a positive test charge. I am using the word test charge. Inside the electrolyte, okay, is called voltage drop. So what is this voltage drop? Mathematically we will write. So mathematically I can write that V equal to W by Q. I used here small v, small w just to differentiate it from potential difference or the electromotive force. Now, what is the relationship between E.M.F and terminal voltage? We'll see. Relation between E.M.F and terminal voltage. Listen carefully. Now I can write this W stands for work done for carrying the charge in the entire circuit. This is the terminal voltage, work done for carrying the charge in external circuit. The small w I have used for work done carrying the charge inside the cell or inside the electrolyte. To differentiate, I have mentioned like this way. So this is the work done for electromotive force. this is work done for terminal voltage or the voltage. This is the work done for voltage drop. For example, now I shall divide by Q. Then what is this? What is this? W by Q. I can write this epsilon is equal to terminal voltage plus voltage drop. So this is important. Listen carefully. So electromotive force is the sum of terminal voltage or potential difference and the voltage drop. So if I want to write this is the terminal voltage form, I can write epsilon minus V. You can mention like this way. So from this it is clear that electromotive force is greater than terminal voltage. Electromotive force is greater than terminal voltage. Now listen carefully. When the cell is in a circuit, or you can say that when we are drawing the current, during that time the potential difference what we measure, we say that is the terminal voltage, and I said that electromotive force is more than terminal voltage. How it is more than the terminal voltage? Because whenever, suppose this is the cell, one is positive end, one is negative end. This cell we are charging by supplying the current. How much current, or you can say how much current we are supplying or we are drawing, it depends upon the how much work done. If more current is flowing, more work will be done, more energy will be spent, or you can say that voltage drop will be more. How much work it will do, that much voltage will drop, or we can say that the work will be done more, energy will be spent more, so the drop also will be more. So that voltage it no use for us. That's why we say that is the voltage drop. Okay. So regarding other factors associated with the voltage drop, definitely you learn in the higher classes. What is necessary for your 10th class, that one I am saying to you. Okay children. So this is the relationship between terminal voltage and electromotive force. Let us light on the fact what we discussed in the previous class, potential difference and the electromotive force. One thing I want to say that when the cell is in a circuit, a complete circuit, the potential difference between its two ends, we say voltage or potential difference. When the cell is not in use, we say it is electromotive force. So electromotive force is more than potential difference, or you can say more than the terminal voltage. So all time electromotive force more than the terminal voltage. But how much more? Or you can say terminal voltage is less than electromotive force. I can say that terminal voltage less than electromotive force. How much less? How much energy is spent for carrying the charge inside the electrolyte? Because when cell work, some work done by its chemical process to carry the charged particles. So I said that terminal voltage less than electromotive force. In what condition terminal voltage and electromotive force both will be equal? When the cell is not in use, terminal voltage and the electromotive force both are equal. But that time, if it is in a circuit, closed circuit, that time electromotive force will be more than terminal voltage. But when it is not in use, that time electromotive force will be equal to terminal voltage. So children, I hope that you might have understood the topic. So I hope some more comment from you. So your comment definitely will help me to improve in the standard of my teaching. If anything is there, you can comment on me. So I said that you don't forget to share this video with your friends. Thank you. Jai Hind.